Welcome to this video on reinforcement learning. While the term reinforcement learning might sound new to you, it is increasingly being used across industries for making decisions in uncertain circumstances. It uses the principles of stochasticity and probability to make decisions in real time and smoothly perform the desired tasks. Let's start with a bit of a background. Machine learning in its early days was basically of two types, supervised and unsupervised. In supervised learning, the data is labeled. That means for every observation, we know what would be the target value. The model is trained to make predictions based on labeled data. On the other hand, unsupervised learning is based on data where labels are not present. The model tries to identify patterns and structures within the data. Both of these methods have their own strengths and weaknesses, owing to which other types of learning emerged. One of them is semi-supervised learning, a blend of the previous two approaches. It uses a small amount of labeled data along with a large amount of unlabeled data to build the models. Another type is reinforcement learning, where models learn by experience through a reward penalty scheme. The models learn through trial and error, receiving rewards or penalties based on their actions. This method is heavily used in areas like policy creation and consumption reduction. Q-learning is a standout algorithm here, teaching models to make the best decisions by maximizing the cumulative rewards. Now that you are through with the difference between the different techniques, let's take a deeper look at reinforcement learning. Reinforcement learning is a specific area of machine learning that emphasizes learning optimal behaviors within an environment to maximize the rewards through interaction and feedback mechanisms. This process is characterized by the use of trial and error method, where an agent learns from the outcomes of its actions rather than being explicitly taught. The central focus of reinforcement learning is on decision making, where the learning agent must assess various states within an environment and choose actions that yield the highest cumulative reward over time. This involves understanding a policy or a strategy that delineates the agent's behavior or aligns it based on the various states it experiences, allowing it to refine its strategy or policy in pursuit of optimal outcomes. Reinforcement learning revolves around the interaction between the agent and its environment, where the agent perceives its state, takes an action, and receives feedback in the form of rewards or punishments. This feedback is crucial as it informs the agent whether its actions are beneficial or detrimental, guiding its learning process towards maximizing the future rewards. Let us understand the key concepts of reinforcement learning in a bit more detail before we move further to the applications. The key components of reinforcement learning include the agent, the environment, rewards, and policies. Each of these play an essential role in the learning process. Understanding these components is crucial for building effective RL systems that can learn to make complex decisions through interaction and adaptation. By carefully designing the agent, defining the environment, setting up appropriate rewards, and selecting or learning an optimal policy, we can create RL models capable of solving challenging problems in dynamic and uncertain settings. Let's learn about each of these components one by one. The agent. An agent in reinforcement learning is the decision-making entity responsible for taking actions in the environment. It interacts with the environment by observing its current state, choosing actions based on the policy, and receiving a feedback in the form of rewards or penalties based on those actions. The agent's objective is to learn a strategy that maximizes the total cumulative reward it can achieve over time by adjusting its actions according to the feedback received. The environment. The environment represents the external context in which the agent operates. It is dynamic and provides the agent with the states that it can be in after each action is taken. The environment also determines the rewards associated with each state action pair, which is crucial for the learning process. Essentially, the environment is responsible for simulating the conditions and outcomes that the agent must navigate in order to learn optimal behaviors. Rewards. The rewards in reinforcement learning serve as a feedback signal, informing the agent about the desirability of its actions. If it does a good action, there is a reward. If it does a bad action, there is a penalty or punishment. Now, rewards can be immediate or delayed and are used to indicate whether the agent's actions were beneficial or not. A well-defined reward function is critical as it directly influences the agent's motivation to learn specific behaviors, and it encourages the agent to explore actions that yield higher future rewards. Policies. A policy is a strategy that the agent employs to decide which action to take given the current state of the environment. It can be deterministic or stochastic, defining the agent's behavior over time. The goal of reinforcement learning is often to optimize this policy to maximize the expected rewards. Updates to the policy can be guided by state values or action values derived from the agent's interactions with the environment, allowing for continuous improvement over time. These four components, agents, environment, rewards, and policies, form the foundation of reinforcement learning. Together, they encapsulate the interaction dynamics that allow an agent to learn from its experiences, adapt to its environment, and ultimately make informed decisions that maximize its rewards. Understanding these concepts is essential for implementing effective reinforcement learning algorithms and applications. Now let's talk about the applications. Reinforcement learning is behind some of the most advanced AI systems today. For example, it's being used in the self-driving cars to navigate the unpredictable environments, in recommendation systems to improve the user experience and retention, in healthcare to optimize the treatment strategies, especially in the case of cancers, etc. It is also being used in various other applications, as you can see on the screen, in the energy sector for adaptive decision control, for regulating temperatures, for regulating the fuel consumption, etc. So this is a very popular example of AlphaGo that I'll be discussing here. So AlphaGo was developed by DeepMind, and it uses reinforcement learning to play the game of Go. And the interesting part is that it has mastered the complex game of Go. The system utilized deep reinforcement learning, effectively integrating the advanced neural networks, specifically a policy network for move selection and a value network for win prediction. This innovative architecture allowed AlphaGo to outperform human champions by mastering strategies through self-play and exploration, ultimately defeating the renowned player Lee Sedol in a historic match. Next, in the medical field, reinforcement learning is being employed to develop robotic surgical assistants. These robots, which are capable of performing surgeries, are enhancing the precision during delicate procedures. These systems leverage RL or reinforcement learning to improve their performance through continuous learning from simulated and real world scenarios. Therefore, they are significantly increasing the effectiveness of surgical interventions. The adaptability achieved through reinforcement learning allows these assistants to respond dynamically to unpredictable situations during surgery. Reinforcement learning plays a critical role in the development of self driving cars or autonomous cars. It enables these vehicles to learn from their driving experiences and adapt to the dynamic environments. This continual learning process helps the car refine its strategies for navigating complex traffic scenarios, adapting to various conditions and unpredictable behaviors from other road users. Reinforcement learning allows autonomous vehicles to improve their decision making process through trial and error, interactions with the surroundings, ultimately leading to safer and more efficient driving behaviors. Companies like Waymo and Tesla have been utilizing reinforcement learning to enhance their autonomous driving systems. Waymo applies a combination of imitation and RL approaches, leveraging large scale real world driving data to improve performance in challenging scenarios. Tesla also uses RL alongside other machine learning techniques to refine its autonomous capabilities, benefiting from the vast amounts of driving data collected by its fleet. Lastly, we have the recommendation systems of today. Reinforcement learning enhances these recommendation systems by enabling them to learn from user interactions and adapt to their preferences over time. It might be possible that a person is interested in watching romantic movies today, and tomorrow, or maybe some months later, the person stops watching romantic movies and starts watching comedy movies. So, this reinforcement learning algorithm will be capable of understanding the change in interest or the change in preferences over time. In this context, the recommendation process is framed as a sequential decision mining task, where the state represents the current content viewed by the user, the action corresponds to the recommended new content, and the reward is derived from the user's feedback, such as reviews or engagement metrics, or click on the given recommendation. Reinforcement learning facilitates a balance between exploration, that is, trying to find out new recommendations, and exploitation, reinforcing successful recommendations, allowing systems to improve continuously as the user interest to evolve. We'll be discussing more about the exploration exploitation trade off in reinforcement learning later in this course. This approach proves beneficial in various domains, including e commerce and content streaming, where it helps in personalizing user experiences and enhancing satisfaction, ultimately driving higher engagement and conversion rates. If you're aware about the recommendations on Amazon and Netflix and Spotify, you are quite sure where reinforcement learning is being used. With that, reinforcement learning is a powerful and increasingly relevant area. It is particularly effective for solving complex, dynamic problems where the optimal solution is not obvious. This includes areas like robotics, autonomous vehicles, game playing, and even finance, where traditional methods may fall short. It is incredibly versatile, allowing it to adapt to changes and learn optimal strategies even in uncertain or complex scenarios. Learning reinforcement learning opens the door to contributing to cutting edge technology and innovation. Moreover, expertise in this area can significantly boost career prospects. From tech giants like Google and Facebook to startups and research institutions, there is a high demand for professionals with reinforcement learning skills to work on advanced AI projects. In our course, we will dive deep into the fundamentals of reinforcement learning, explore advanced algorithms like Q learning and deep Q learning networks, and work on real world projects to solidify your understanding. By the end, you'll be equipped to design and implement your own RL solutions for complex dynamic problems.
Thanks for watching the video. Our knowledge partners, certification alliances, and curriculum creators are. Join our popular courses and get an immersive learning experience as we proudly serve as a global trailblazing training solutions provider, dealing with grinding a revolution in upskilling by offering comprehensive and specialized training programs. Following are our services: instructor-led virtual training, on-site training, corporate training, exclusive and individual training, self-paced training, classroom training, customized training, campus training. To know more about our courses, visit our website. Don't forget to like, share and subscribe the video.